Hello everyone, welcome to the Boiler Experience Sharing channel of DIVI Group. Today I will introduce the working principle of a fluidized bed biomass-fired boiler, water tube type with 2 drums, designed and manufactured by DIVI Boiler, DIVI Group. First, let's look at the types of fuel suitable for this technology: rice husk, wood chips, sawdust, cashew shells, shredded wood waste, and more. In addition, the boiler can also operate with fossil fuels such as coal. Fuel is transported from the storage hopper via conveyor to the intermediate hopper. From here, thanks to the hopper's inclination and the feeding air fan, fuel is smoothly delivered into the furnace, while preventing backfire. Inside the furnace, fuel is evenly spread over the grate surface, continuously burning with sufficient oxygen and temperature. Hot flue gas rises to the steam-generating tube bank above. A secondary air fan supplies additional oxygen to ensure complete combustion and minimize CO emissions. Water flowing inside the steam tubes absorbs heat from the furnace, generating about 60% of the total steam through radiation heat transfer. Next, the hot flue gas enters the convective heat exchanger section with 2 drums. Here, water inside the tubes absorbs heat from the flue gas, generating more steam, which is collected in the upper steam drum. Approximately 40% of the steam is produced in this convective section. Coarse ash and dust are retained in the bottom hopper and discharged through a rotary valve. At this stage, flue gas still carries 250 to 300 degrees Celsius of heat, so it passes through the economizer to recover residual heat. With a tube-in-tube design, water inside, gas outside, feed water is preheated up to 150 degrees Celsius, significantly improving efficiency. After that, flue gas at 180 to 200 degrees Celsius enters the air preheater, heating the combustion air to nearly 100 degrees Celsius. This enhances fuel burnout and boosts overall boiler efficiency up to 89%. Ash collected here is also removed via the ash hopper and rotary valve. The main forced draft fan blows preheated air into the furnace to support combustion. Flue gas, after heat recovery, enters a multi-cyclone dust collector, which removes most of the larger ash particles. Ash falls into the hopper and is discharged by rotary valves. Remaining fine dust is captured by a bag filter system. Flue gas passes through fabric bags, where fine dust adheres to the surface. When dust builds up, compressed air is pulsed inside the bags. Dislodging dust into the hopper below for removal. All collected ash is conveyed by screw conveyors to the storage area. An induced draft fan maintains flue gas flow through the boiler, heat recovery units, and dust removal system. Finally, flue gas undergoes wet scrubbing via a Venturi water spray system, ensuring clean exhaust before release through the stack. The deaerator removes dissolved oxygen from feed water, preventing corrosion inside the boiler. The feed water tank stores sufficient water for at least 1 hour of continuous operation. High-pressure pumps deliver water from the tank into the boiler continuously, matching steam demand and water levels in the drum. Before entering the boiler, feed water is treated by a water treatment system to meet quality standards. The steam header collects steam from multiple boilers, then distributes it to production units. It also helps dry the steam before use. The entire control system is installed in an air-conditioned control room to ensure stability and durability. Only 1 to 2 operators per shift are required to manage the whole system. That is the working principle of the 2-drum water tube fluidized bed biomass boiler, designed and installed by DIVI Boiler. This technology has already been applied in many projects across Vietnam. DIVI's fluidized bed biomass boilers comply with international standards, such as EVFTA, Precept, EVFTA, PRECEP, CPTPP, and more. At the same time, they contribute to Vietnam's commitment to the Paris Agreement on climate change.